This is my video for Lab 4, Arithmetic Logic Unit. In this lab, we are separated into 4 different sections. First section right here on the left side is the A input for numbers that we're going to be inputting. This one right here is the B input. In the middle here represents our flag bits. So first one we have is 0, overflow, negative, and carryout. And then over here we have our command input, where we input certain binary numbers to change the function of what we're going to be doing. So addition, subtraction, multiplication, and or XOR, all that stuff. So first I'll go ahead and demonstrate addition in this case. So for addition to work, all these switches need to be down. As you can see, they're all down, so on 0. So we're currently in the addition mode. So we'll just go ahead and demonstrate it. So over here, the A input, so we'll start with our first number that we're going to be adding. So the first number we'll be using, we'll just start with 1. So that's on 1. And then the second number we'll also be using 1. So we'll just do 1 plus 1, which if done correctly, over here, LED right here is shining on the second from the right. So basically 0, 0, 1, 0, which is equivalent to 2. So that does mean that the addition worked right here. So the next command we'll be doing is subtraction. For subtraction, we just need to flip up the least significant bit, which is the far right switch. So LED 0, the one that's on LED 0. So we've switched it to subtraction. So we'll start by taking 8 minus 1. So we'll start by taking 8 minus 1. So we just need to flip up this switch right here for the A input. So that should be equal to 8. And then over here in the second input, B input, we just switch it to 1, which we just need to flip up this switch. So now it's 8 minus 1, which obviously done correctly, we can see that the 3 lights shine up right here, as you can see, and we have 7. So this is equivalent to 7. So 0, 1, 1, 1, which is equivalent to 7 in binary. So there we go. We know that one works. So that's my subtraction one. The next command that we'll do is the A plus 1 command. So in order for the A plus 1 command to work, we just need to move up this switch right here. So it's in A plus 1 mode. So basically, it's already working right now. As you can see, we have no inputs in, so we have just 0 right here in the A input, so 0. And it's automatically taking that 0 and adding a 1 to it. So as you can see, we already have just 1 right here. So it's obviously working. But for the sake of the video, I'll do another switch up. So we'll just do 2. So when I flip up this switch, we should see 3 over here, and we do. So 0, 0, 1, 1, which is equal to 3. So we flipped up this switch, which made this number 2. It added 1 to it, and now we have 3. The next command input is multiplication. In order for multiplication to be activated, we need to flip up this switch and this switch. So right here, we have these 2 switches flipped up, the 2 from the right flipped up, so now it's in multiplication. So we'll go ahead and multiply the biggest number that we possibly can. So the 2 biggest numbers is obviously 15. So we'll just flip up all these switches. And what you'll notice is that we have now filled up the flag bit section, which is a little bit insane because these really shouldn't be activated, but they need to be on because we have multiplied a big number and it's needing to take up all these LED spaces in order to display the proper number that we're trying to display here. So that's why it takes up some of the flag bits right here. It is in order to showcase the number that we're trying to do, because it's 15 times 15, so which will be 225. So as you can see, we have 225 right here. The next command input is AND. So in order for AND to be activated, we need to switch up this switch right here. So 0, 1, 0, 0. So it's in the AND function. So we'll start with the number 1, 0, 1, 0. So as you can see, 1, 0, 1, 0. And then for the second number in the B input, we'll do 0, 1, 0, 1. So when these two numbers are ANDed together, we should get the result of 0, 0, 0, which as you can see, all the LEDs are off, indicating that the AND function does work, and we are receiving all zeros in the LEDs. The next command input that we're using is OR. So I've already went ahead and put it in right here. So we have this switch up and this switch up, so 0, 1, 0, 1, which it's in the OR function. So if we go over here and we use the same numbers that we used last time, 1, 0, 1, 0, and 0, 1, 0, 1. So when we OR these two numbers together, we should get resulting number of 15, which we do right here. All the LEDs are lit up, so we have 1, 1, 1, 1. So that is correct. The OR function is working properly. All the LEDs are lit up. The next command input that we're using is XOR. So for XOR to be activated, we have to first input 0, 1, 1, 0, which will give us XOR. So now the two numbers that I've decided to XOR are right here. So we have on the A input, we have all the switches up. And on the B input, we have 0, 1, 0, 1. So when we XOR these two numbers together, the resulting number should result in 1, 0, 1, 0, which as you can see, it does. We have 1, 0, 1, 0 in the LEDs that are lit up. So the XOR function is working properly. The last command that we're going to be using is NOT, and for NOT to be lit up, we just need to flip up these three switches. So the NOT is already in play, as you can see, even while we haven't even put any inputs in, because technically this is 0, and it not only matters for the A input. So as you can see, A is at 0 right now, so the opposite of 4 zeros would be obviously 4 ones, and as you can see, it's working right here. So we'll input all ones for the A part, and over here it should result in all LEDs off or 0, 0, 0. So all zeros across the board, and it does. And as you can see, we see that the LED 7 is on for the 0 flag bit as well. So that just helps further show that this is working properly. This is the end of my lab video. I hope all of the inputs were correctly shown, and thank you for watching.